tomorrow is about how to model the human behavior, how we can, what are the concepts and the assumptions we have to do when we are dealing with a model that takes into account the human behavior. And this is something that is related to the decision and game theory. This is a picture of the place where I come from. This is Bariloche. Okay. And before we start, I wanted to do an activity with you. I have some. So I need you to do a very brief activity, and this is something that we will discuss at the end of the section related to decision theory. So this is what you have to do. Suppose that there is an urn that is containing 19 balls. 30 of these balls we know that are red, and the remaining 60 balls are either black or yellow. We don't know the proportion of how much yellow or how much black balls we have. The only thing we know is that we have a remaining 60 balls that are divided into either black or yellow. The balls are well mixed so that each ball is as likely to be drawn as any other. And the first thing you have to do is the following. Suppose that you have to choose between these two situations. I will take a ball. If the ball is red, I will give you 100 reales. If the ball is, but if it is red, if you choose A, I will give you 100 reales, but if the ball is black or is yellow, I will give you nothing. And the choice B is, I take the ball and the ball is black, you will receive 100 reales, but if the ball is red or yellow, you will get nothing. So please make a choice. So once you, this should be more or less quickly. If you choose A, is that you think that the ball I will take is red, okay? And B, if you think that the ball I will take is black, okay? So I will take a ball. If you choose A and the ball I take is red, you choose A, you will get 100. If not, you will get nothing. But if you choose B, so if the ball I am taking is black, you will get 100. Okay, this is. So please make a choice between A and B. So I can go to the next situation. Okay. Now I have the following. You have to choose between C and D. If you choose C and I take a ball, and the ball is either red or yellow, you will take 100, okay? And D, if I take a ball and the ball is either black or yellow, you will get 100. That means that if you choose C and the ball is black, you get nothing, and if you choose D and the ball is red, you get nothing. So please make a choice between C and D. It's okay? Okay. So we will get back to this later. I want to discuss something that is called the Ellsberg paradox. And I need to analyze your choices to see whether it is working or not here. Statistically, there is a paradox that is related to the usual choice of people. And I want to discuss that. But I also wanted to use you as subjects for an experiment to see whether this paradox is also occurring here or not. Okay, so Later, I will collect your answers, and I will make analysis of the answers, and we will discuss this paradox. Okay. So let's begin with the difference between decision and game theory. They are more or less the same, but there is a very interesting and decisive difference. Both decision and game theory are concerned with the reasoning process underlying people's choices. So they are just trying to understand how people think about a given situation at the moment of taking a decision. But the difference is that, okay, the goal is to study either how people, in fact, reason about their choices. And the difference is the following. Decision theory is concerned only with an individual decision. So there is only one person that has to make a decision, also taking into account different things, different precepts, and different concepts and ideas. And the idea is that this individual decision maker, what is going to do, or what is trying to do, is to make the best decision based on his or her understanding of the situation. So when we are talking about decision theory, we are talking about only one individual. When we are talking about game theory, we are talking about several individuals that are taking the decision at the same time. So if I am an individual, I am not only need to consider what I think about the situation or about my own ideas, but also about what the other person is going to do. It's a sort of competition. This is why we call this a game, because I am not alone in the decision making, but I need to compete to take into account the decision of the other. The other can be only one person or can be a group of persons. So this is more or less this is mainly the big difference and the main difference between decision theory and game theory. In decision theory, there is only one person. In game theory, there is a group of persons, a group of people. And when I am talking about decision theory, we have an individual and his or her ideas. When we are talking about game theory, we have a group. And into this group, there are several ideas and there are several behaviors. So each person needs to take into account the decision of the others, okay, for the final result. So let's talk about a classical problem in decision theory is, for example, what attitude to risk and uncertainty are rationally permissible. So, I mean, what is what I can risk, what is what I can do, and the idea is that, as I told you, this risk and these concepts are only based on my own decisions, my own ideas, on my own history. Okay. A classical problem in game theory, on the contrary, is whether rationality requires one to free ride other. Or I will mention this. For example, in game theory, we have to choose how to proceed, how to act, or how to behave. But for example, I will mention what is, I will tell you what is rationality in the next slide. But for example, in game theory, we assume all of us will behave in a rational way. But sometimes there are people that do not behave in a rational way. So the idea is how to anticipate the possibility of other people not behaving in the rational way. So in decision theory, it's only me. In game theory, it's not only me, it's also taking into account the rest of the people. Okay, so let's talk about rational choice. This is a very important concept in game theory and in decision theory, the idea of rationality. Because we are departing, or we assume that the behavior of any of the individuals is rational, and I will define what is rational. So decisions are made by individuals that try to maximize their benefits and minimize the cost. This is the idea of rationality. I will take a decision that will give me the highest reward, or the highest possible reward, and in case I have no possibility to evade the risk of a loss, I will behave in a way that this loss will be the lowest possible loss. Okay? Players make decisions about how to act or adopt a strategy by comparing these costs and benefits, and this is something that we will call payoff on different actions. So the cost and the benefits is what we call the payoff, and the behavior or the decision is what we call the strategy. So these two words are very important in decision theory and in game theory. Strategy is what I decide to do. Payoff is what I will gain or lose once I have adopted a given strategy. So these two concepts, payoff and strategy, are very important. The idea of rational choice is not new. I will read a paragraph from a book by Adam Smith. He says that it is not from the benevolence of the butcher, the brewer, or the baker that we expect our dinner, but from their regard to their own interest. So it's not that the butcher, the brewer, is just giving the beer or the beef because they like us. It is because they want to earn something. Okay? So his idea is that in any interaction between people, there is always an individual interest. And this individual interest is related to a rational individual that only wants to get the highest possible payoff. There is another quote that I wanted to mention. This is by John Stuart Mill in 1836, and this is from his book, Political Economy. And he says, political economy does not treat the whole of man's nature as modified by the social state, nor of the whole behavior or conduct of a man in society. It is concerned with him, the individual, solely as a being who desires to possess wealth and who is capable of judging the comparative efficacy of means for obtaining that end. So this is telling us that the individual only wants to increase his or her wealth, and he knows or she knows how to do that. And this is the rational behavior. This is what we call the rational choice. From the idea of rational choice, we can jump to another concept, and this is the concept of homo economicus. An homo economicus is an individual that acts to obtain the greatest welfare for himself or herself using all the available information on opportunities and constraints. In a way, it suggests a rational, selfish, and effort-averse individual. So this is the idea of an homo economicus. That an homo economicus is an individual that only wants to increase his or her wealth, and this is the only important goal. And also, that individual is informed about how to do to obtain this wealth, what to do to obtain his wealth. As I mentioned earlier, the idea of homo economicus is linked to the idea of rational choice, and the idea as something that was defined very clearly comes from the works by Lionel Robbins in the 20th century. And again, a summary of the ideas is individuals always tend to maximize their utility or benefit and tend to reduce cost or risk. So it's always the same. And this is the individual that we are taking as a subject to model the human behavior. But there are some criticism, and this is something that we can discuss. And one of the stronger criticisms is that in reality, we don't behave as homo economicus. We live in a society, we have friends, we have family, and could be that there is a huge proportion of the population that behaves in a very selfish way, but there is also altruism, there is also cooperation. So it could be that we are not pure homo economicus. So Ralph Dahrendorf, that was or is a sociologist, he suggested the idea of homo sociologicus, that is a concept to refer to the image of a human or human nature, with which many sociological models try to limit the social forces that determine the individual taste and social values. The idea is that in reality, when we analyze the human behavior, we actually can see that humans do not behave as Homo economicus. So the idea is that actually we behave as Homo sociologicus, that is the concept of a human being that lives in a society, and despite that the nature of the human could be very selfish, the society tends to domesticate this selfishness and make the individual to behave in a more fair way. So this is something that is not taken into account in what I will be telling you about decision theory and game theory, but this is something that should be taken into account at the moment of discussing whether the models are valid or not. So another important concept we need to understand or to know is the utility theory, that is also something linked to decision theory. Utility theory based its beliefs upon individual preferences. Explain the behavior of an individual based on the premise that people can consistently rank. This is something important to rank, to make decisions and to compare these decisions. So they can rank, order the choices depending upon their preferences. That means that if I have to make a decision or I have to make a choice, I can rank all the possibilities and to evaluate all the possibilities and decide, okay, this is the first one, the second one, I can rank them. Okay? So the idea is that there is something that is called the utility, and I will use this utility in order to rank my decisions. So it's like evaluating which is the highest payoff, and I will put, as my first choice will be the one with the highest payoff, the second with the second payoff. So the idea is that always we can define the utility of a given action and to compare different utilities to decide what we are going to do at the moment of taking a decision. So utility theory is a positive theory that seeks to explain the individual's observed behavior and choices. Okay, as I have told you before, the idea is that there is something that is called utility, there is something that is measurable, and this utility is the amount that will let us to make a rank of our decisions. The utility theory makes these following assumptions, and this is very important. Completeness means that individuals can rank or can order all possible situations, no matter how many combinations or assumptions we have to do. There is always the possibility of rank the decisions. There is no situation where I cannot make a choice. There is no situation where I cannot make a rank of my decisions. So there is no ambiguity. This is one of the assumptions of the utility theory, and this is called the completeness. Okay? More is better. This assumes that the individual prefers a good, for example, if I prefer A to B, and then I increase the amount of A, for example, I increase the amount of A by alpha multiplied by A with alpha greater than 1. So I will choose alpha times A to A, and also I will choose alpha times A to B. So the idea is more is better. If I have make a choice based on a given quantity that can be measured, and then there is another choice that has a high, or that represents a highest amount of this quantity, so I will prefer the one that has, or that will give me the highest payoff. So more is better is one of the assumptions linked to utility theory. And you can understand that more is better is closely related to the idea of a rational individual, because a rational individual will always choose more is better. So this property is called a monotonicity assumption on preferences. That means that I will always choose, if I have two situations or two possibilities, I will always choose the better one, the best one. Okay. Mix is better, and this is called convexity. And the idea is that suppose that an individual is indifferent to the choice between two options, and For example, if I have A and B and they are alike, I cannot make a decision because they are the same to me. So instead of choosing A and choosing B, I will choose a mixture between A and B. So if there is no possibility of decided between two situations, I will choose not one of them, but a mixture of both. So this is called the mix is better or the convexity assumption for the utility theory. And then is rationality, something that we have already discussed. So these four properties, completeness, so I can always make a choice, more is better, I will choose the possibility or the option that will give me the highest payoff. Mix is better, if there are two options that will give me the same payoff, I will choose a combination of them instead of only one of them. And rationality, and this is the most important and also controversial, that for example, an individual, if A is preferred to B and B is preferred to C, then A is also preferred to C. So this is rationality. I will always choose the best one, and I will, under no condition, decide to choose or to make a choice that will give me a lower payoff than before. So let's go to decision theory. Decision theory involves economic and statistical approaches for studying one individual choice, and also is named theory of choice. And this is important. This is an individual choice, but an individual that is isolated. There are no other individuals. It's one individual faced to himself or herself and in the need of making a decision. So it enables an entity is an individual, to make the most rational decision, the most possible rational decision, in an unknown and uncertain condition, repercussion on behaviors. So decision theory is what will give this individual the tools to make a decision if the information is not enough. So how I can make the decision, so I will try to think about the concept of rational choice and be able to make a decision. This theory analyzes how and why a person made a decision, the reasons for that decision, and when and where that decision was made. Because also location and time are crucial in decision making. So as I mentioned before, this theory analyzes the behavior of an individual at the moment of making a decision. Mathematicians, economists, marketers, data and social scientists, many others, use two different theory forms for decision theory. One is called the normative decision theory, and the other one is called the descriptive decision theory. I will mention in a moment what is each of them. Decision theory helps also to a consumer or a professional to make, again, a rational choice. And it is based, or the theory is based, or is the basis of understanding a successful business, marketing strategy, and behavioral changes. So, again, decision theory uses economic and statistical approaches. There is something that is called operation research that is linked to this research that takes decision theory as a tool. This research is called operation research, and it functions as a flow of tasks in one strategy. So I will show you this flow, how it works, and what we call the operation research. This is just to mention that, but I will give you an example. So these are the areas of application of decision theory: psychology, biology, philosophy, politics, mathematics, economics, physics is not here, but data and social sciences and business. So decision theory permeates a lot of areas of the knowledge. And there are two types of decision theory: the normative decision theory, that is when the decision analyzes the repercussions of ideal, and this is ideal logical decisions, based on a set of values. So normative decision theory is what we are going to analyze here, and is related to consider that we have a rational human being. We have a rational decision maker. So in the normative decision theory, there are norms. These norms are based on a set of values, and it is not considering other situations that cannot be formalized in terms of rationality. On the other hand, we have optimal decision theory that is not qualitative, but this is quantitative. It's mainly quantitative, but sometimes it is also qualitative, but it is known as a descriptive decision theory because it examines the decision made by irrational people. So contrary to what we are doing here in a normative decision theory, that we have clear rules because we have the individuals that is rational and is predictable, and we know how the way of taking a decision will proceed. When we are talking about optimal decision theory, we are dealing with irrational people. So we cannot proceed in the same way as we will proceed with the normative decision theory. This theory employs not only one, but several number of frameworks, hypotheses, and functions to understand and comprehend the practical actions that follow a set of norms. So instead of assuming a behavior, in this situation, in the optimal decision theory, we don't know anything about the decision of the behavior of the people. We cannot anticipate the decision of the people because they behave in a very rational way. So, yes, irrational means that, yes, it's not the homo economicus. It's not the person that will prefer, that will always try to look for the best selfish decision and behave in a way that cannot be predictable. Yes.
Is it rational because it is not homo economicus?
Yes.
You are not talking about maybe values have some payoff for people.
Yes, for example,
and that's what I want to know, if irrational is just because they don't want to have the most economic profit.
Yes. Oh. For example, suppose that you have something for your family, and you will proceed in a given situation. Maybe you will make a choice that is not just for you. It's not the best choice, but it is the best for you and your brother, sister, and mate, or whatever it is. It's like, it's not only the economical interest involved in this interaction, but there are some affections, and there are some things that are not rational. There are some emotions that cannot be characterized as rational. So if you are moved by some motivations that cannot be qualified as rational, you will behave in an irrational way. And you will do things that maybe cannot be anticipated. Or maybe it can be anticipated, but not by considering the paradigm of a rational decision maker. That's the idea. So we are not working with this situation. We are not working with the optimal decision theory, but we are just giving examples of this normative decision theory. And okay, and the idea is one of the activities or one of the debates I want to promote is to talk about how comprehensive this normative decision theory is. If we are going to make a model, it is fine, it is enough just to consider this normative decision theory, or we need to look ahead and to consider and to put into our model different things. So this is something that I want to discuss with you. Yes.
But irrational people, and just to close it, irrational people are not taking decisions randomly.
No. Not necessarily.
Not necessarily. Okay.
It could be.
Okay. It can.
Yeah,
okay.
It could be, but also, it could be that they are not behaving in a random way, but you cannot anticipate the behavior. That's the point.
Okay. 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 Thank you.
So it is not only that something is stochastic, but that it's your lack of knowledge that cannot anticipate the behavior of it. And this lack of knowledge could be because you don't know how someone will react, or because this person is acting in a random way.
The hypothesis of transition, completeness, and
Yes.
and monotonicity
Monotonicity. Yes.
are applied to irrational.
No.
No, okay.
No. The utility theory is only applied to the normative decision theory,
Okay.
and it's not working for the irrational actors.
Okay.
Yeah.
Marcelo, I'm sorry to disrupt you.
Yes. No, it's okay.
We are talking about rationality as it was irrationally made by the bourgeois at the middle of the 19th century. The authors you mentioned
Yes.
are the liberals.
Yes.
And we can make other rationalities, restricted rationalities. For example, a biological rationality.
Yes. I will mention this. Yes.
Because we could play games
Yes.
with other sort of rationalities, I believe.
Yeah. This is called bounded rationality, and I will mention this in the next slides. Okay. Yes. Thanks. So let's come back to some examples. Okay. So this is just a summary of what I have been saying. So normative decision theory analyzes the outcomes of decisions, determines the optimal decision based on these outcomes, and when I mention optimal, is based on the utility theory, and the theory centers around the ideal decision maker for a specific situation. Ideal here is a synonym of rational. On the other side, decision theory is the investigation of analysis of why individuals and agents of choice make the decision that they do. So here I am trying to predict the decisions, and here I'm trying to understand the decisions. So this is something that will let me to predict always within the frame of a rational individual. And here what I'm trying to do is to understand what has happened. So I can use normative decision theory. The people will behave in a different way, so I will need to understand why they have behaved in the way they did. And also, it looks at the assumptions made by individuals making the decisions. So the approach is different. I am trying, maybe I start with this. If this is not working, I will need to go on with this. And with this, I can build a new concept of rationality, something that Hernán was mentioning, what is called bounded rationality. Because if this is not working, it's because the idea of a pure rational individual is not working well enough, so I will need to redefine the idea of rationality. So what are the elements of theory decision? There is a set of possible future conditions that exist and that will have a bearing of the result of the decision. So at a given moment, I can anticipate what are, or not anticipate, I can imagine what are the possible situations that I will need to face. So I have to make a decision because I need that after taking the decision, there will be a result. Right? There will be a consequence because of me taking the decision. But to be able to take the decision, I need to anticipate what will happen once I have taken the decision. So this is the set of possibly future conditions that will exist once I take the decision. There is a list of alternatives. These are the strategies. This list is all possible choices I can make. And also there is a payoff for each alternative. So I have the consequence of my decisions, a payoff for this consequence. So I know the consequence, and I have to give a value for all this consequence. This is something that is related to the utility theory. I can rank all the possibilities, the future possibilities, and to reach these possibilities, I need to make a choice. So there is a list of alternative choices that will...
A doubt.
Yes.
The decision is about the payoff of the next step. It's not a long-term prediction, or it could be anyone.
Well, ideally, in the formulation of decision theory, there is you take a decision that will involve a next step. I am not talking about time. I don't know if the next step will be, for example, we have to in a couple of weeks there are elections in Argentina. So I have to make a choice, but I don't know if my decision will have immediate consequences or not.
No, I was wondering if I could put inside this framework the rationality of saying, if I take this decision and I assume everybody's making this decision like I am doing, which is the kind of society I get, and then rank my decisions because of this extrapolated final state.
Yeah, but this is game theory. This is not decision making, because in this case there are several actors involved, and I have to make a decision in terms of what the other individuals will do. So I will mention that, but this is within the frame of game theory. Here, the decision is only related to me or myself and nothing else. I am not taking into account what the other people will do, because it's not important. In the frame of decision making, it's only me. Okay. Maybe the example of the elections was not the best one, but for example, today you decided to come here and to leave the hotel at the same time you usually do, and you came here quite late. That was a decision you take only by yourself, and it was a bad decision because you were here at 9:50. 15, sorry. Yes.
And you have at least two prices.
Yes.
And there is a rationality because you don't like fish. For instance.
Yeah, for example, yes. Yeah, for example, the fish is very cheap, and it's cheaper than the meat, but you like much more the meat. So what will you do? So you have to make a decision.
Right.
And you need to know whether you have enough money or not, or if the difference. Even if you like meat more than fish, maybe the difference in price will not compensate the horrible taste of fish.
Is this true that this utility theory doesn't fit with this type of behavior where you comment about collectivity?
Yes.
They don't fit. You cannot put together the
No.
two ideas.
No, you cannot put them together.
Okay, and until now, you are telling us that you cannot, let's say, change behavior. You cannot be one guy at some point and some space, and then you change it because you are in another.
The idea is that I have a deterministic system, so I cannot change. And what I can do, for example, if I want to manipulate people, I can change the payoff, just to make people to make a different choice by judging the payoff of each of the choices. But the individual is a deterministic individual, so I cannot change the behavior of that individual. I cannot make that individual to make a choice or to choose an option that has a lower payoff. But what I can do is just to manipulate the payoff, for example. And this is the way to manipulate the decision-making individuals. Okay. So there, as I mentioned here, there are some. At the moment, I have to make a decision. I am not very sure about what will happen. Maybe I know exactly the future, but sometimes I don't know the future, and there are some probabilities of a given event to occur. So there are some uncertainties that I will have to deal with. There are three types of uncertainty that can be found in decision-making theory. And this uncertainty has to do with my possibility to predict exactly or not predict exactly what is going to happen. Usually, we cannot read the future, we cannot tell the future, so there is some uncertainty that we will need to deal with in order to make a decision, okay? So there are different types of these uncertainties. The first one is the states that encompass facts that exist in the universe that can affect the decision. So there are different states, and when I make a decision, I will change from one state to the other, but I cannot be sure if the transition, sometimes the transition is deterministic, not the choice of the individual. The transition from one state to the other is deterministic, but sometimes it is probabilistic. So I cannot be sure about this transition from the present state to the future state once I make the decision. The other is, so I cannot be sure that, I suppose that, going back to the states, I suppose that I am in these states, and I assume that by making this decision, or sometimes I make a given decision in terms of what I suppose that it will be happening in the future. For example, going back to the fish and meat, I cannot know exactly the flavor or the taste of the meat. I imagine that the meat will be much better than the fish, but I don't know. Maybe I am going to a restaurant that the specialty is fish and the meat is terrible, and I assume that meat will be better than fish, and it is in the opposite way. So the state I assume here is that if I choose meat, I will get a better dish, but sometimes this is not right. So there are some, the state, the anticipation of the state is one of the uncertainties I will need to deal with. Consequences. Once I make a decision, I am not sure what will be the consequences of this decision. For example, going back to the elections, I assume that I will vote for a candidate because this candidate has been promising wonderful things, and we know the politicians. So the consequence cannot be anticipated. So I choose a candidate because I like the proposals, but then this candidate does whatever he or she wants to do. So sometimes the consequences of my actions cannot be anticipated. I can predict with some error or anticipate with some probability what is going to happen and what will be the consequences, but I cannot be sure of the consequences. So I have to deal with this uncertainty about the consequences. So consequences are the future of a decision that influence a decision maker on a micro level. Okay. And then the actions. The actions are the link between the states and the consequence. So we have states. The state is the state at which I am before making the choice, and there is another state that is the state at which I will be after making the choice. There are consequences that are a result of my decision. At the moment, I am in a given state. I will move to a different state, and in this state, there will be consequences. And the actions are the bridge to make a transition from one state to the other one. I need to make an action. I have to make a decision. Okay.
The definition of individual.
Yes.
Because in this case, for example, a lot of myself are killing themselves just to maintain my individuality. So
yes.
This is like my question, the definition of individual in this case.
Individual is individual. What you are talking about is something that I will mention when we deal with game theory. For example, a species is an individual. No, a species is a collection of individuals. And in this case, what we will see is that within the population there are different strategies. And as there are different strategies, individuals from a given population can choose, each of them can choose a different strategy. So there is a competition between strategies, and you can see that collectively there is a behavior of the whole population. But inside, at the microscopic level, you will see that there are different choices. This is what you, okay, see, I will mention, we will see situations where something like that happens, and it is more framed by game theory rather than decision theory. As I mentioned before, it is almost the same. The frontier between decision theory and game theory is very thin. And sometimes you don't know where you are. But one thing that is clear is that when you are talking about decision theory, you have only one individual that is not affected by any other individual. So this is something that is very clear. The rest of the cases can be discussed, whether a population that is behaving collectively is an individual or not. I would prefer to frame this within game theory, but it's my choice. Okay.
So what about the assumption that the payoff might be bigger in the future? This happens in investment, for example.
Yeah, this is, for example, this is one of this is one of these uncertainty you have to deal with.
Right, but so an individual might make a decision
yes.
at a certain point for which the payoff is not ideal.
Yes.
But then you wouldn't call them irrational, right? They're just assuming that the payoff will be bigger in the future.
Yes.
Is there a way to describe this, like a dynamic payoff?
Okay, but the individual assumes that it will be bigger, and
right.
Under this assumption, and he takes this assumption as something that will be sure or something like that. It's like, anyway, either I cannot anticipate the future, I will behave in the way that I assume that will be the best for me. Right. So I don't know the future, and maybe I am not sure about the payoff to increase, but I suppose that the payoff will increase, and I take the decision considering this assumption. So in this way, I am rational. I will never choose, I will never make a decision if I have the minimum risk of going against my desire, going against my wealth. So even if I don't know what will happen, I always make a decision in terms of what I can anticipate that will happen, in terms of this uncertainty that I am mentioned here. So the consequences are not always very clear, but even if they are not clear, I will behave following my assumption of what is going to happen.
Okay, thank you.
Yes.
I was going to ask, and then how you build your payoff for the future. But now I think what you do is to, you have the futures.
Yes.
I'm thinking you have the futures, and I don't know how you can predict. So you have a preference for the futures.
Okay, I will mention this in the next slides.
Okay.
Okay.
I didn't know, I just guessed.
So this is something that is related with your question. So I can have certainty if the environment in which the relevant parameters, I know exactly everything, but also there is some risk. When I don't know what is going to happen, there is a risk, so I need to evaluate this risk. And even if I don't know what is happening, what I'm trying to do is to minimize the risk. And in this action, I am behaving in a rational way. So I need to minimize the risk. The risk is related to uncertainty, because if I know what is going to happen, there is no risk. If I don't know, there is a risk. So I will try to minimize the risk. So certainty is an environment in which the relevant parameters have known values, but risk is when the environment, there is some future events that have probable outcomes, but I don't know exactly what is going to happen. There is a probability, and there is an assumption of the probability. And I behave by maximizing or minimizing the risk in terms of these probabilities. Sometimes I know the probabilities. Even if I know probabilities, the scenario is not a deterministic scenario because it is a probabilistic scenario. And sometimes I don't even know the probabilities. So I will talk about these scenarios in the next slides. And uncertainty, so there are 3 different scenarios. This is the best one, when I know exactly what is going to happen. This is when I don't know exactly what is going to happen, but I know the probabilities of each of the events. So I can make a choice by considering certain probabilities and minimizing the risk, even if I'm not sure of the future. And the worst scenario is this scenario when I don't know exactly nothing. I don't know what is going to happen, and I don't know the probabilities of the future events. So this is the best one, when I know exactly, I can predict the future. This is when I can predict with a given probability the future, and this is when I have no idea of what is going to happen. And this is the worst scenario, and in this moment, when I am facing this scenario, I am not making a rational choice. It's just a guess, because I cannot predict anything. I cannot choose, I cannot use my rational abilities to make a choice, because I don't know what is going to happen. So, yes.
But in that last scenario,
yes,
you know the possible outcomes, right?
Yes, but
But you can't assign that probability.
Yes, yes.
I mean, I will add a last one that is like not knowing even what are the possible outcomes.
Yes.
That's an even worse scenario, I think.
Yes, yes.
Okay.
Yes.
Yeah.
So, decision-making under certainty is a decision maker that know for sure the outcome or consequences of every decision alternative.
In the last one, in the uncertainty scenario, maybe some people tend to go to that place even if there is not very, it's awkward to go to that place, but even that you are trying to minimize the risk, you know that if you take risk, your reward could be better. So it's like in the market, for example, the risk is very higher, but there are possible rewards very higher too. So
yeah, but the market is perfect. So if the reward is high, the possibility of losing is also very high.
Yes,
so the risk is high. Yes. For example, the market is something, an example for this. In order for a market to be perfect, what we call perfect, is that if the possible reward is high, the risk associated with the reward should be also high to compensate. Because if not, you will not be in this scenario, will be in this scenario, and the market will not be perfect and can be manipulated. We know that the market can be manipulated, but the idea of the market, the ideal market is a perfect market when we are dealing with this sort of scenario. We cannot anticipate the future, and if there is a high reward, it should be associated to a high risk.
Yes. Okay, thanks.
Can you be rational in this last scenario of certainty?
No. No, here you can be rational, but it is not, it will not pay you being rational because there is nothing you can do. So you have to guess. So rationality is not useful in this scenario. So we are dealing with, we will talk about these two situations, certainty and risk. We are not going to talk about this one. So a decision making under certainty is a decision maker that knows for sure the outcome of the consequences of every decision alternative. And decision making under uncertainty, the decision maker has no information at all about different outcomes of state of nature. So this is something that we are not going to treat or to mention in the following slides. But we are talking about this other situation, that is decision making under risk. It's a decision maker that has some knowledge regarding probability of occurrence of each outcomes of state of future. So in this situation and in this situation, you can be rational. Here, rationality is the right thing to do because you can anticipate the future, so you will behave rationally. Here, rationality is used in terms of the probability. You cannot know for sure what is going to happen, but you can evaluate the probabilities and the payoff of each of the situations, so you can use rationality to make the best choice by considering these probabilities. But in this scenario, there is nothing you can do. So we will talk about this scenario, but not this one. Okay. For example, the profit let's go to some examples. The profit per unit is 5. You have an order for 200 units. How much profit will you make? You know. So you have to multiply 5 by 200, and this is what you will get. The other one is risk. Profit is 5 per unit. Based on previous experience, there is a 50% chance of an order for 100 units or 50% chance of an order for 200 units. What is the expected profit, given that you have a cost to produce these units? So if you don't know if you will sell all of the units, because there is a probability of selling all of them or only selling 100 of them. So in this case, you need to make a decision. What is the decision? I will produce 100 or I will produce 200, because there is a cost in producing a given item. So if I produce 200, but then I only can sell 100, I will need to pay the cost of producing 100 items that will not be sold to anyone. So the decision here is between what to do, produce 100 or produce 200, given that there is this probability. And the other situation is this one. The profit is 5 per unit. The probabilities of potential demands are unknown. So I am risking because I don't know. I will produce how many items do I need to produce? 100, 5, 200. I don't know. So this is only a guess. Maybe I know nothing. I even don't know the history of. I have no guess about the probabilities of potential demands. So in this situation, I cannot make a rational decision because I don't know what to do.
Could I ask something?
Yes.
On the situation on a 50% probability of an order of 100 and an order of 200?
Yes.
I think it is kind of rational to produce 200 because if you produce 200 units and you're asked for 200, you will get a payoff for that. If you are asked for 100, you will get a payoff for that. But if you only produce 100, you could get no payoff because you are ordered 200 and not 100.
Yeah, but that depends on how much, what is the cost of producing something without selling it?
Yes, I guess.
Okay, that's the problem.
In the same in the same question, if you know what is the cost of producing the unit, is it still risk, or because you don't know the outcome of the probability?
Yes.
Or is considered risk? Okay.
Yes.
So in this second example, we can think about the guy pick up the middle decision that it produce like 150. Can be the case?
Okay, you are behaving rationally. Okay, that's the choice, for example. But to do that, you need to rationalize the whole problem and trying to make calculations and understand which will be the... So you are, even if you cannot predict the future, you are behaving in a rational way. But here, there's nothing you can do. So that's why I said before that in these two situations, even in this situation, if you don't know exactly what is going to happen, you can behave rationally. But in this case, there is no possibilities of behaving rationally. Yeah.
I don't know, maybe it's not rationality, but there are some other things, because if you are producing, you know how much money you have, you know how much money you can lose.
Yes.
So you will produce something that you are not afraid to lose, and maybe you gain, and the next time you will have some input. So I don't know if it's really irrational.
But there is no, okay, but you are supposing that there is a next time. There is no next time here.
No, but
this is the situation.
the first time, I suppose you will produce, I think, you will produce something that if you don't sell, doesn't lead you to bankruptcy,
Yes.
right? And I think it's rational.
There's only one time. There is no next time. So you have this problem, so what to do?
Yeah, there is one short situation. There is not next time. This is an example, okay. But even if in what you are proposing, in the next time you will behave rationally. You are encompassing the situation just to avoid this situation and to go to this one. So here you can behave rationally. Okay, so you are changing the scenario.
Yes, I know, but I think in that I understand the irrationality in concept, but I think even in irrationality you have some rationality.
Yes, well, could be, yes. 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 Yeah.
But I understand the rule. The rule is
Okay.
if you don't know what is going to happen, you are acting irrationally. Sorry. But I understand the rule. I understand the rule of this game.
Okay. Okay. Okay, let's just a summary of the process of decision theory. First, you have to identify possible future conditions that are called the state of nature. For example, the demand will be low, medium, or high. Then you have to develop a list of possible alternatives, possible choices, possible decisions, one of which will be do nothing. For example, you can do nothing. This is a possible action, a possible choice. And then you have to determine the payoff associated with each of the choices you have here. This is the process of decision theory. I will just go to this situation. So if the decision maker does not know with certainty which state of nature will occur, then he or she is said to be making decision under uncertainty. This is something we have already mentioned. Now, let's go to the 5 commonly used criteria for decision making under risk. I will, instead of uncertainty, I will use the risk word here. There is an optimistic approach. We will call this maximax. There is a conservative approach. We will call this maximin. The minimax regret approach, that is the minimax regret. The equally likely, that is the Laplace criterion, and the criterion of realism with alpha, that is the Hurwitz criterion. I will give you an example of each of them. The optimistic approach is the following. It will be used by any optimistic decision maker. The decision with the largest possible payoff is chosen. If the payoff, for example, is in terms of cost, the decision with the lowest cost will be chosen. So in the optimistic approach, I'll always make the decision to choose the decision with the highest payoff because I am optimistic. Okay. The conservative approach would be used by a conservative decision maker. For each decision, there is a minimum payoff, or the decision, the minimum payoff for each is listed, and the decision. So what you do is to choose the maximum payoff of the minimum payoff. So in the, with the example, it will be clearer. So in the conservative approach, the idea is that each decision has a minimum payoff. So for each decision, we have a maximum payoff or a minimum payoff, because there is, it's not clear what is going to happen. So there is a probability. So in terms of this probability, there is a maximum payoff and a minimum payoff. So a conservative decision maker will just take or consider that the worst scenario is the one that will be occurring. So considering this worst scenario, the decision maker chooses in this worst scenario the possibility with the best or the highest payoff. Okay. The optimistic decision maker just considers that the best situation is the one that will be occurring, so he or she chooses the highest payoff. In the conservative approach, the decision maker considers that the worst scenario is the one that will be occurring, and in this worst scenario, he or she decided to choose the highest payoff.
I have a doubt.
Yes.
In these approaches, because we discussed the risky on the environment,
yes,
and the risky profile, I don't know, propensity for risk or
yes,
risk aversion or neutral aversion, neutral risk. This can be this information about the decision maker profile
yes,
is inside in these
yes,
approaches?
Yes. This is, for example, what the banks do when they make a profile of you as an investment. They ask you some questions and they decide whether you are an optimistic or a conservative investor or an optimistic investor, and they decide what you have to do with, or they propose what you have to do with your money. This is the profile you are mentioning about the propensity to the risk, for example.
Okay, so the optimism and the,
yes,
it's linked to the
yes,
risk profile.
Yes, for example, an optimistic decision maker is someone who has a risk aversion very low. A conservative decision maker is one that has a risk aversion very high.
And how this is the convexity hypothesis, how this is different when you have
no, because in
the risky profile
in the convexity approach, we were talking about the utility theory. Here we are talking about the decision making theory. So the utility is the same. The utility, the scenario for the convexity was a situation when you have all the information about what is going to happen. In this situation, you can also build up a function that is convex, but taking into account all the probabilities and using these probabilities to build up your. You can do the same, but you have to take into account the probabilities, to weight all the possibilities with the probabilities. Yes.
So the optimistic will be like a gambler, or no, something like that?
Like?
Someone gambling.
Yes, yes. Well, gambling, yes, because when you are gambling, you have some probabilities of yeah, if you are a good player, you know the probabilities.
Yeah,
okay.
If you know your probabilities, you won't gamble.
Yes.
You won't play the roulette.
Yes, for example, the poker players, the professional poker players, they count the cards and they can calculate the probabilities, and this is what makes them good players. A bad player is just playing at a guess. A professional player is playing by weighting the risk and knowing what to do at a given moment. So I will give you examples. Suppose that these are the states and these are the decisions. So I have two decisions and two possible states. So if in the future the state or the future state is S1, so if I choose D1, I will get 20. If I choose D2, I will weigh 25. I will get 25. But if the scenario is S2, if I choose D1, I will get 6, and if I choose D2, I will get 3. So an optimistic decision maker will just choose the highest payoff, that will be 25. On the contrary, a conservative decision maker will choose 6, because he or she will consider that the worst scenario is the one that is going to happen. This is the worst scenario because the payoff is lower than here. But in this scenario, this decision maker will choose the one with the highest payoff. Okay. So coming back, there is another strategy that is the minimum regret approach that requires the construction of a regret table. I will show you how to construct this table. The regret table is done by calculating for each state of nature the difference between each payoff and the largest payoff of any state of the nature. So let's go to the example. For example, the minimax regret payoff, what I am going to do is to build up, so this is the table of the payoff, and what I do is, in this situation, I make the difference between the highest payoff and all the payoff. For example, this is 25 minus 25, this is 25 minus 20, this is 6 minus 6, and this is 6 minus 3. So what I am doing is subtracting from the payoff, or the highest payoff, the value that is in the table for each of the situations. So here I subtract from 25, 20, and 25, and here I subtract from 6, 6, and 3. So this is somehow a measure of what I will be losing because I have made a bad decision. This is the regret. So if I choose this one, and the state S1 is the one that is happening, and I choose D2, my regret will be 0 because I have chosen the best decision. So I will get the highest payoff. But if I choose D1 and the situation S1 is happening, I will have a regret because not having chosen the right situation. And this regret can be measured, and is 5. It's the difference between what I will have obtained if I had made the right decision. And the same here. Okay? So once I have this regret table, what I do is I select the decision with the minimum regret. That is this one. So I am not considering this and this. I am considering the situation with the minimum regret. And the minimum regret is this one, is 3. So I have to choose between these two, and what I do is I choose this one. So this is the decision with the minimum regret. And a minimax regret approach will let me to make this choice. So I will choose this one. Yes.
So in this minimax regret approach, you will never choose a maximum utility.
No, you will not. The idea is that. No, you will not use. I mean, what you do is to make a choice. It's not that you will not make you will not choose this one, because at the end you are choosing D2. Okay, what you do is just to choose the minimum regret. You know that there will be a situation here and here that will be 0. So this is discarded. Okay. What you do is just between these two, you choose the one that has the lowest regret approach. If it's not that you are choosing 3, you are choosing D2. Okay? But D2 has a lowest regret, a minimum regret in this situation. So if S1 is, for example, if here, for example, instead of having 3, you have 0, okay? So the regret would have been 6 in this case. So you would have chosen this, D1 instead of D2.
Okay.
Okay?
In this case, there are only two decisions.
Yes.
But what if there is a third decision so that...
you do the same.
You do the same.
You do the same, yes. You always choose the one that has the lowest regret. And maybe just to avoid the confusion, it's not that you are choosing this one, you are choosing this one, okay?
And I just wanted to ask the same, but maybe I'll just add to add comprehension. So if you have many situations that could happen, you don't do an addition of them, you just choose the one that has the lowest value?
Yes.
Or just the lowest value?
Yes, yes.
Okay, okay. So it doesn't matter if there's an accumulation of more regret in one row?
Okay, yeah, well, if you have three choices, no, I think that the right thing to do is just to add up all the whole regret, the whole value, and adopt the lowest of them. Yes,
okay.
You are right.
Okay.
Yes, yes,
Thank
you are right. Yes. Okay, we'll stop here and for coffee, and we'll come back. Okay, when we come back, I will mention the other two that I have listed, the equally likely Laplace criterion and the Hurwitz criterion.
Os papelzinhos.
Sí. Point